is equal to Q naught is equal to 2 into 2, 4 coulomb. This is the initial charge in one of the capacitors. What about charge in other capacitors? 0. I'll close the switch. Then after closing the switch, we should bother about that initial charge or charge at an isolated junction. This is a circuit we have 6 volt, 2 volt, and all these are 1 farad, 3 farad, and 2 farad. Now tell me like what you're going to do. Some charges are the series parallel. We don't know anything. So I'm going to go for charges like this. Q1 minus Q1, Q2 minus Q2, here Q3 minus Q3. And the positive, negative. Plate will be positive, negative. Look at this particular junction. The moment you close switch, what will be the charge of this junction? So junction means here you try to bother. I'll shade it. We should bother about. We have option of colors, no? So what should be the charge of these 3 plates? The moment I close switch, what is the charge at that point? It is plus Q naught. So charge of these 3 plates must be conserved, no? Able to understand this one? It's like a bucket idea again. The same idea of bucket. Capacitor means I said bucket, no, equivalent to bucket. So the similar thing what you can apply here. Okay, now this is what is the charge of this 3 plates initially Q naught. Finally, what happened? It should be equal to Q naught here. Okay, now let's write at shall I call isolated junction? What do you mean by isolated? Because there is no any other cell is connected here. So definitely you can call this as isolated junction. At isolated conservation of charge. Junction J. So what was the initial charge? It was like a Q naught. Final charge, it should be Q3 minus Q1 plus Q2. Okay, how to find out that? Apply KVL. But sir, like a charge again should be conserved. Okay, now again, what is the charge of a cell should be conserved? What charge left the positive terminal of cell 6 volt? The same positive charge should enter here. Like that, we should cross check for that conservation of charge later on. Whether we are right or wrong, the charge of a cell should be conserved. There's a charge at isolated junction. So let's write loop equation now. This will be plus 6 minus Q1 by 1 minus Q2 by 3 minus 2 equal to 0. Or this 4 is equal to Q1 minus Q2. Let me write one more equation. Plus 6 minus Q1 by 1 minus Q3 by 2 equal to 0. I'm tracing the loop like this. Plus 6 minus Q1 by 1 minus Q3 by 2 equal to 0. Okay, this will be 6 is equal to Q1. This is positive, no? One more we needed. So plus 2 plus Q2 by 3 minus Q3 by 2 equal to 0. So this should be equal to 2 equal to Q3 by 2 minus Q2 by 3. Solving 1, 2, 3, we'll get the thing. So he is asking each generator. I think we must know the charges Q1, Q2. Then only I can do something in the problem. Anybody? Q1, Q2, Q3?
Q1 10 by 3, Q2 2, Q3 16 by 3.
Wait. So slowly. Q1 10 by 3.
Q2 2, Q3 16 by 3.
All are positive. Huh?
Yes, sir.
Okay, now you have to ask one best question to teacher. Sir, how do you can say this is a positive net? I too don't know, to be frank. I just assume. Sir, I'll assume minus Q1 plus Q1. Okay, solve it. If you get negative, change the polarity. Change the polarity. That's the only alternative available for us. Okay, now what was earlier? What was the charge of this plate? Okay, now come for this plate. No, I'm giving green color to this plate here. Look at the green color plate. What was the earlier charge? Similar to like a bucket. So what was the charge here? 0. Now finally, what was the charge Q1? So what charge has flown here? Q1 charge should flow here. So we'll give some flow like this. Huh? Let a You have to trace out a charge. For that, I'll take help of positive plate of any one capacitor. Okay, this capacitor C1. So what was earlier? So 0 plus QA and it has become Q1. So we know Q1. So therefore, what is QA equal to? So that same QA should flow here also. Now let's come for this one. What was the earlier charge of this plate? What was the 0? Now it has become minus Q2. So what do we expect? Some positive charge has flown like this. So that charge flown. Let me bring like this here. Sir, how come you are saying, okay, why don't you put QB? It's left to you, anything that one. I'm taking here entered, I took positive. Intentionally, I'm taking the charge left here. Okay, let's do one thing. For the green color plate, this is, no, brown color plate. Brown color plate. What was the earlier charge? 0. Some charge left. Charge left means you should take negative. And finally, how much of charge? Q2. So therefore, what is QB is equal to 2 coulomb. Okay, try to see this symbol. I would have taken QB positive, but I wanted to make students to learn. If a charge leaves a plate, it should be negative. If a charge enters, it should be positive. Convention, okay, now I think why positive, why negative? Charge left negative, charge entered positive. So QB, I got it. Now QB, how do it will enter? QB will pass. Okay, now let's look at the Q3. What was the earlier charge of any plate? You take the lower plate, this one. What was the charge of this? Yeah, there's a red color plate. You can pick up any one. It's left to you. I'm just picking up this one. Or no, sir, I'll take positive plate. Okay, it's left to you. So any one. Let me choose this one. Now look at the red color plate here. For red color plate, what was the earlier charge? Minus Q naught. And finally, it has become minus Q naught is 4 coulomb and it has become 16 by 3. 16 by 3, definitely the value is 5. So I'll assume that some charge entered. So plus QC and it has become minus Q3. Q naught was how much? Minus 4 minus 16 by 3. So QC should be equal to minus 4 by 3 coulomb. What do you mean by negative? Some charge left here. Again, for me, let me do one thing. I'll assume charge left only, because in the final I have to Okay, this will be negative. Okay, I think it's justified, no? So what is the charge at this junction? QA is how much? QA is 10 by 3. Then QC plus QB add up. So every way the charge must be considered. What charge entered here, that much should leave. And what charge entered positive, that much should leave. Like that, all pen, what all, if you go wrong anywhere in mathematics, no, definitely everything here, QC plus QB will not be equal to QA. And what charge entered, that much should leave. So like that, all pen, everything will get disturbed here. So therefore, definitely all pen, somewhere like when you are ending up the problem, check like a conservation of charge at a junction. If it is a valid, okay, then your mathematics is correct. Okay, after getting all this, okay, now I think, shall we go for heat generated? Because they will help us to check whether this one. What this battery? Positive charge leaves positive terminal. Then battery should do positive work. If positive charge enters positive terminal, battery does negative work. Now tell me like a what shall I do for heat generated? Any formula for heat generated? Initial energy plus work done by, okay, this is cell 1, cell 2, W1, work done by it, W2, final energy plus E. I think in every numerical, what will be the numerical? Whether some spring is there, some any piston is there, what will be the circumstance? Let's not bother. This will be the generalized formula everywhere. If like a work done by extra agent will come, okay, that work by extra agent, okay, let it be here. See, I can also, in this problem also, I can pull this plate. I'll be doing work. Hearing this one. So that you are going to bring it, work done by extra agent, work done by the cell. This is a generalized formula. Please carry on in all every numerical, irrespective of numerical, whether spring force, friction, external force is there, tension, any other agent does work here. So that has to be included here. So you, I think if you look at the electromagnetism, there I think yes, just say that if action agent also is involved in doing work in the system, that has to be substituted here. He has made it really very beautiful. And again, don't read it. No use. Just this information was there. I just wanted to share you that one. Of course, we don't do any problem. Okay, that one in advance they may ask you. So work done by action agent in pulling this plate from D to 2D. So that you include here. Okay, now initial energy. So Q naught square by 2C4 plus work done by the cell QA into 6. Then this cell will do negative work QB into 2. Final potential energy Q1 square by 2C1 Q2 square by 2C2. Solve for this, you'll get the heat generated. I think I did the same problem in the book where this capacitor were not there. I just brought one this capacitor, and that too with initial charge. Earlier in regular class, we had a problem where this capacitor was not there. With this capacitor charge, let it be. You can manage. Now, sir, what about charge flow here? Yes, you can take help of this one. What was earlier charge minus Q1, so some charge should leave here. So you can trace it. Same QA charge will come. Your QB charge, your QC. Anybody having doubt, you can just ask me. There's a very popular problem. Same thing I think we did in regular class without this capacitor and initial charge. Now with capacitor and initial charge, I brought it. I'll scroll down. Solve it later on. Solve for H.
20 by 3.
H equal to this much.
Yes, sir.
Okay, somebody verify it. Okay, now we'll go for the next one.